without any further ado, we're going to start our session today. And in our session today, Yono is going to cover the Label Studio, what is Label Studio, and the integration that we have with DagsHub, and how you can automate your process or your annotation process. If you have any questions, if you have any comments, we'd love to hear them. We will add some links to the chat here, to our Discord channel, and also Yono has some links there. We'd love to get your feedback and know what other sessions you'd like us to cover next. So this is part of the DagsHub learning series. Each time we're going to cover a different open source tool that helps us as data scientists to either manage our project or to move faster to production. So if you have any requests, or if you want to dive deeper into tools that we already had covered, such as the MLflow, the DVC, DDA, and now Label Studio, please let us know. We'll share the link to our community Discord, and we welcome all of you to join it and also join DagsHub. So with that, and without any more introductions, I welcome Yono.
Thanks, Nir. Hello, everyone. Welcome. I just want to say before we get started, since we don't know everyone's level in whether they've used Label Studio, are new to it or not, this webinar is going to start fairly simple, but it's going to get pretty complex towards the end fairly quickly. If you get lost at all, don't worry. We're here to help. You can always message us afterwards if you have any questions after you've looked through the material a little bit more too. So with that, I'm going to go ahead and share my screen. And it's Spider-Man. We'll find the slides. Okay, Label Studio 101. So these, everyone can see the slides, right? Give me a thumbs up, somebody. Yep, great. Okay, so we're going to start with a demo because that's the best way to get started. And actually, let's not think of this as a demo. I'm going to be your waiter today. You're going to enjoy a 3-course meal. This demo, though, is going to be a preview of the dessert. The dessert takes 30 to 45 minutes to cook. I got to send it back to the chef in the back. So we're going to give you a preview of what it looks like before we start with the appetizer. And for this demo, what I'm going to do is I'm going to show you the final result of using our machine learning backend with Label Studio. So what I'm going to do is I'm going to go ahead and start my server here. Don't worry if you don't know what I'm doing right here. It's going to be explained later. It's just going to be a quick demo. I'm going to fork this tiny squirrel data set from DagsHub. And I actually cheated a little bit. I already forked it before, so it went a little bit quicker. But I'm going to bring up our annotations. I'm going to click on the ML demo project, which I already set up. I'll show you how to set up a project later. It was perfect, though, because it loaded up in the meantime. So we lost no time whatsoever. All right, what I'm going to do is you can see on the right-hand side, the server is running. I'm going to select all 20 of our data, all 20 of our images, and I'm going to retrieve predictions. Now, this will give me a little box I'm going to explain later, but I'm just going to click it away. And you should start seeing things downloading on the right-hand side in the terminal. And apparently it's got them cached, so it's not downloading them, but pretend like it's downloading them. It would have downloaded them if it was the first time. It's sending responses. And if I click this refresh button, we'll see a whole bunch of predictions appear in Label Studio. This is basically what was happening is Label Studio is sending all the data to my server here at home. It was running a machine learning model, which was then running inference on those images, and then sending the predictions back to Label Studio. And if we open up an example image, you'll see it actually successfully detected a squirrel because the model is actually pretty good. So we're going to go ahead and submit that. We'll look at this one, another squirrel, that's good too. And just for fun, we're going to do one more. There's no squirrel there, perfect. Okay, so now we're going to commit those, and we'll see those maybe a little bit later. So that is the end of our preview of our dessert. So we're going to get to all of that later. Let's go back to our appetizer. So what is Label Studio? Well, if you just gathered, this is an open source data labeling platform. So it's not like every other labeling platform, but it is an open source labeling platform. You can annotate data on there. You can organize your data fairly easily. It's very flexible, which is great. It's easy to use and it has an intuitive UI. I was able to, I first learned about Label Studio when I came to DagsHub half a year ago or so, and I was able to learn it fairly quickly. It supports many different data types. So you just saw images, but it supports a lot more. We're going to go through them in a little bit. And as you also saw, it supports machine learning assisted labeling, which is fantastic. So it's flexible enough that we can actually run our own machine learning models and have it help us with our labeling. It doesn't matter if your machine learning pipeline is a standard supervised machine learning pipeline. Label Studio will help you with this area roughly. Or if you have a more exotic active learning pipeline, Label Studio is still good for you because it'll help you with this area. So essentially, any kind of labeling you need to do, Label Studio can help you with. Let's go quickly over some of the supported data types. You saw images, but in addition to the data types, what's also important is what kind of annotations it supports on them. As you can see, in not just bounding boxes, which you saw with the squirrels, it also does segmentation either with polygons or with masks. It does key point labeling and others. Along with audio, you can hear and see your audio waveforms in the interface, in the UI interface, and you can then use it to annotate, for instance, speech recognition or speaker segmentation or sound events. It supports video, which is kind of like images and audio put together, right? So it's an obvious next step. Text, which is very big nowadays, especially with stuff like ChatGPT and your text-to-image models. But text is good for summarization or semantic. Sorry, I forget the word. But like, let's go with text classification and partitioning. Structured data, if you need to pull data out of HTML or PDFs, it's good with that. And time series. So when you're writing your next machine learning model to predict stock prices and make $1 million, Label Studio is there for you too. It's got you covered. Before we get a little bit further, I do want to take some time to explain some terminology, not a lot of terminology, just a little bit that tripped me up when I first started. And I wanted to make sure I clarified them so that it's not a stumbling point. So let's talk about data. Now, we all know what data is. I'm not underestimating your intelligence, but I just want to make a point here. So data is, of course, interesting stuff to annotate. However, data is not what you give to your annotator within Label Studio. And this is what confused me initially. It's because you give your annotator a task. And what's the difference between a task and data? Well, a task is a single piece of data that's ready to be predicted. It's part of an entire job. And most importantly, it includes metadata relevant for predicting or annotating. So it's got all the information you need to be able to correctly annotate the data. So the difference is subtle, but it's an important difference, especially when you start looking at, say, Label Studio's API, and you're wondering, how do I upload data? Well, maybe you need to look at tasks instead, or vice versa. Another interesting subtle difference might be prediction. Well, again, I don't want to insult your intelligence, but just to make things absolutely clear, we're talking about inference output from a machine learning model, much like in our demo we just had. That's different from an annotation, which is human created or approved. So what my machine learning model was doing, it wasn't returning annotated data back to Label Studio, it was returning a prediction. This prediction could then be turned into an annotation by a human annotator or a labeler. Okay, very subtle difference, but important to know so you don't trip yourself up. But Label Studio is great, but more importantly is, how does DagsHub integrate Label Studio? Or even better question to ask would be, how does DagsHub improve upon the labeling process using Label Studio? And this is actually where things get pretty exciting. So DagsHub has a repository each repository in DagsHub has a Label Studio workspace that can be attached to it. These workspaces have full access to your project files. Now, that sounds obvious, right? But think about it a little bit more. You no longer have to copy or you move your data around to get it labeled. This is extremely important. This is a very convenient thing. You don't have to upload to a server somewhere and just to get some stuff labeled. You don't have to email some pictures to your mom to get her to draw boxes around stuff anymore. You have it already in your repository, and Label Studio has access to it. So you can immediately start getting the labeling process going. You can have multiple labeling projects per workspace, but what's very cool is that you have a unique GitFlow for labeling. And let's talk about GitFlow really quickly. We'll do a little refresher in case you're not familiar with GitFlow or you don't know what that terminology means. GitFlow is, let's say you start with a repository. You have the main repository, the original repository, and it's got a commit. You want to start updating that repository from that commit, but you don't own that repository. So what do? You fork the original repository. You start making some changes and committing them. Maybe simultaneously, the original repo is also making changes and committing them. Well, you've come to the end of the changes that you want to make. So what do? You open a pull request back to the original repo. Today is a good day. The repo owner likes your pull request and wants to merge it back into his original repo or his or her original repo. This is fantastic. And now, though, a great part is someone could be simultaneously making other changes while you were making your changes, and they can all be merged back together using Git. Now, this is what we're used to doing with code, right? However, DagsHub's integration with Label Studio allows you to do this with data annotations. And if you think about that, that is extremely powerful. This gets me excited a lot. So imagine you have a lot of data that you need to have annotated. You have friends that can also do annotating, or let's just call it crowdsourcing annotations. Or let's say crowdsourcing, making a data set. Everyone can fork this original repo. They can annotate small sections of the data and merge them back in, and you start to fill in a big picture over time. So suddenly you're not doing 100,000 annotations, but you're spreading the work among a lot of people who are collaborating on labeling this data for you. And that's where this GitFlow comes into play. Additionally, if you ever find that your model is diverging, like let's say you realize, hey, your model has diverged from what you expected to be, and you trace it back to be about a month ago. Because all of this is committed to Git, you can actually go find the commit where the model starts to diverge and start to debug what happened. You can rerun your experiments from that point on, see what changed, see what needs to be changed in order to fix the problem. The other thing, though, is, so how is DagsHub keeping track of these changes to your data annotations? So that gets into the nitty-gritty here. We're going to go over that really quickly so that if you ever come into a problem or if you ever want to see something, you know where to go look. When DagsHub commits your changes to a repo for data, specifically from Label Studio, it creates a hidden .label studio directory. And this hidden .label studio directory is at the top level of the repo. This is the source of truth for DagsHub annotations. Everything that's in there is the truth as far as DagsHub is concerned. The directory is going to contain a label config.xml. And this label config is your label schema. And what do I mean by label schema? Well, let's take a look at an example. This is basically telling Label Studio what kind of data it can expect. So in this case, an image, and what kind of labels or what kind of annotations should be associated with this data. In this case, rectangular labels, so bounding boxes. And you can see that the choices for what a bounding box might be is either Baby Yoda or Mando. Additionally, it has the color choices for the user interface. So this label config is the schema of the label, and it only appears once in that .label studio directory. Additionally, the data that's really important is there is a single JSON file for each of your data files that you've annotated. If you haven't annotated something, there won't be a data file there. But if you've annotated something, DagsHub is going to create a JSON file inside this directory that uses a Label Studio format. And even if, for instance, when we looked earlier, I made 3 changes. I made 3 commits. I did 2 squirrels and 1 nothing, not squirrel. That image where nothing is will also have a JSON file. It will basically say that there are no squirrels found in that image, but it's important to know that it was actually annotated. But however, because this Label Studio directory is a flat directory, how does it deal with naming conflicts? Like say you have the same name under a train and a validation directory. You shouldn't do that, but let's just pretend you do, you made a mistake or something like that. Well, the file name of these JSON files is actually a SHA-1 hash of the path to the data file. This path is including the data file and it's relative to the repo. So it's not the absolute path that's on your computer, it's relative to the repo. So it's always going to be the same regardless of whether you're looking at the repo on DagsHub, you're looking at the repo on Alice's computer, you're looking at the repo on Ram's computer. It's always going to be the same path, the relative path, and then the hash is going to be the same. If it's easier to understand by looking at code, this is how you might generate the name of the JSON file for each data file. So let's pretend you have the image file squirrels, squirrels, you hash it using SHA-1, you digest it, that will give you a 40-character hex string, and you add .json to it, and that's the name of the file in that .label studio directory. Sometimes that's handy to know if you ever need to debug something. Okay, we're going to do a web demo where I'm going to go over a lot of what we just talked about, show you the UI for Label Studio, and show you some other cool stuff. If you want to follow along, this QR code is the repo that I'm going to fork, or that I just forked in the demo, and we'll be showing you around a little bit. Okay, so if we go back here, we go back to our data set. I want to show you something first. If you remember, I committed those changes to the ML demo branch. And in this is my fork repo, right? In here, we see that .label studio directory that I mentioned. If you look here, I'm going to actually make this bigger since we don't need that server window anymore. These represent the 3 files that I annotated. This label config, as you see, is essentially that XML file that I showed the example of. A little bit different because we have squirrels instead of Baby Yoda. But if we click on one of these files, because right now this means nothing to me, I have no idea what file this is, right? But if we click on this file, we're going to see something cool. We're going to actually load the image. So DagsHub recognizes that this file, it knows that this file is associated with an annotation for an image. So it loads the image. Additionally, it'll show you the annotation in there, including the confidence score that was associated with that. Since we used a machine learning backend, each prediction it sent was sent with a confidence score. So now we know how confident it was that this was the squirrel. Additionally, we can then look at the next one. Yep, that's our squirrel again, 97%, great. And if we look at the last one, we should see just grass, nothing. Additionally, you could do it the other way around. If you're looking at if you're browsing your data, DagsHub shows you which images have been annotated by this symbol right here. So none of these have been annotated, but these 3 have. So if we click on one of these, it also tells you in this corner, there's an annotation. Look, it even warned me. There's an annotation in this file. If we click to see this, it'll take you back to the Label Studio directory and show you again what the annotation is for that file. Okay, well, let's go ahead and open up Label Studio. We're going to click on the annotations tab right here. We're going to click on the annotations tab right here. We're going to click on the annotations tab right here. There we go. Perfect. It worked the first time, right? I'm going to show you how to set up a new project. So this is my project for my demo, with the machine learning backend demo. Let's create a new project. This time we're just going to call it demo. I'm going to be very boring. And I'm going to commit to a branch, my cool demo. The reason I want to do this is I don't want to actually make my commits. I want to just create a new branch to start that whole GitFlow process. So later, when we have the option to commit, you have the option to create a new branch to commit, or you can do it ahead of time. I like to do it ahead of time just to make sure I'm on a separate branch and not committing directly to main. So we're going to create that project. And we have to click here to start. This brings up the Label Studio setup interface. So we're not quite in Label Studio yet, we're kind of in it. It defaults to this DagsHub tab, which is where we're going to select our data. But before we do that, if you were to set up your data now and you click save, it'll try to dump you into the Label Studio interface. However, because we haven't defined our labeling structure, it won't happen. So what I'm going to do is we're going to do something a little bit different. You saw the bounding boxes, but let's see something a little bit more interesting. Why don't we check out semantic segmentation with polygons? So we're going to make some really bad looking squirrels. Let's just say that. You have the default airplanes and cars. We don't need those. We're not looking at airplanes or cars. We're going to add a squirrel. We're going to spell it correctly. And I don't like this light red, so I'm going to pick a different color. Let's say a bright blue. I want to allow, this is up to you whether you want this or not. You can zoom with your control on the scroll wheel. You can show the zoom in and out controls. Great. And now I need to move all your pretty faces to the top so I can see the bottom. And I click on save. And now we're going to select our data directory. We have a data directory. We have 20 files in it. That's the correct data directory, just to make sure. We click save. We're not splitting text files because we don't have any text data, and we don't need to worry about treating files as custom tasks. So I'm going to click save. And now, because we've defined the labeling schema and selected our data, we get to see Heidi. This is Heidi. This is Label Studio's mascot, the possum. Okay. Now, in a typical workflow, what you would need to do is you would need to, just to get started, you could just click this button and do label all tasks. And that'll start taking you to a flow where it'll force you, or not force you, it'll give you one image at a time or one piece of data at a time and allow you to label it as you go along. Let's take a look at some of these other options first. So I'm not super interested in, for instance, predictions right now because the machine learning backend will come later, so I don't need to see the predictions column. I don't also need to see the source file path. I am kind of interested in seeing, for instance, maybe we want to see when it was created. So they're all created at the same time. That's not actually that interesting then. Or perhaps an annotation ID. There are no annotations ID. Okay. However, if we wanted to sort by a different field, we could also sort by, for instance, our creation time. That's kind of boring. All right, we'll do sorting later. But let's say we want to label these four tasks first. Remember, not data, tasks. What we can do is then select them, and then if we look here, we can just say label 4 tasks. Okay, so now we have our first squirrel. Congratulations. What we want to do is we want to zoom in. We can zoom in, and we can pan. Oh, we're gonna have to. Okay. Now we're going to label the squirrel by putting dots down. As you can see, it's fairly quick. And this is exactly what the squirrel looks like. He's a little bit like Max Headroom from the 80s, kind of blocky. It's weird that there was a natural squirrel like that. Normally they're a lot more fuzzy. All right, now we have our first squirrel annotated, and we can choose to submit this. And you'll see the count in the commit going up. Every time you submit, then this commit number goes up because you're actually making a change. So it's counting the number of changes that you're making. If we were going to do another one, we're going to do another one really quickly. And I'm doing very roughly just so we can get the idea. Perfect. It looks exactly like that. Submit. We have a commit of 2. Here we have nothing, so we can either skip or we could actually submit is better. If you weren't sure, like let's say, I'm not sure that's a squirrel, that might be, let's say, a groundhog. I don't want to accidentally incorrectly label this, so I'm going to skip this. And I'm done. No more data available for labeling. Now what I can do is I can go and commit this. When you commit, you have the option to actually also generate your annotations and add them to your project directly if you check this box. When you do so, you have a lot of different options of how you generate that data. This data will then be added to your repo and then will be version controlled with your repo. But I'm not going to do that. I'm just going to commit it to my cool demo branch. And now I can continue annotating. When we go back now to our wrong button, we go back to our annotations, we go back to our demo. Back to our demo. We say hello to Heidi again. Okay. What you can see here now is that your completed by times are now based on when you actually hit the submit button. So they're not when you hit that commit button, they're when you hit the submit button. You can see that it was I that annotated them. You see my avatar there, and if you hover over, you can see my name. You can see that this column right here is the number of annotations in the task. And this was the one that I skipped. That way, if you need to later, say, filter by, not image, filter by canceled equals 1. Then you see all the ones that were canceled, and then perhaps you need to revisit those and send them to, say, a higher tier annotator, or have another set of eyes look at them to make sure that it's not what it is. An interesting point is these might also be, if you're doing, these might also be the harder examples you actually want to focus on for training a machine learning model. Let's cancel this. I want to see all the data again. There was something else. Yes. Okay. So you're like, oh, you know what? I forgot to export when I committed. I don't want to have to commit again just to export. We have this lovely export button here, which allows you to export the exact same data. The difference here is this won't export it and attach it to your repo. This will just basically allow you to download it to your computer. So if that's your preferred pipeline, then that's what you would do there. Let me think if there's anything else that we wanted to show before we move on. Yeah, so you can, of course, delete annotations, delete tasks, delete predictions, all that kind of cool stuff. Okay, let's conclude our main course and move back to slides really quickly. Let me see, are we ready for, yes, we're ready for our dessert finally, okay? This might be the reason you're here, is this machine learning back end. So this is also a really exciting part. So you can create a machine learning backend, which then Label Studio talks to get predictions, which you saw in the original demo, or the initial demo. What do you need for your machine learning backend? Well, you may not have noticed, but it was essentially just a machine learning model wrapped around, wrapped in a REST API. The REST API platform, the framework that I used was Fast API because it's a very easy and expressive framework. It's very powerful and it's very quick to get started with. It runs a web server, and this web server defaults to port 9090. You can choose any port you want, but the important thing that you know is that to run your machine learning backend, you have to run a web server, and you have to, within the web server, have a REST API, which can then call into your model. The REST API is now important because Label Studio expects a specific set of endpoints that it can be able to call. So let's go ahead and go over those a little bit. The first one we're going to talk about is the health endpoint. And the health endpoint is a health check. If you don't know what a health check is, it's essentially a way for a client to find out whether a server is up and running. So it calls the health endpoint, and if it gets an expected response of, say, 200, then it knows that the server is up and it can continue doing whatever work it needs to. It doesn't have to guess as to whether or not the service is running. This is called multiple times. Several times when you're connecting your machine learning backend to Label Studio, and at least once before every time you send tasks to be predicted. It is required. If Label Studio does not get an expected response from the health endpoint, it will not connect to it and will refuse to use it. The expected response is a JSON response with the status set to up. And this v2 is the version 2 of the Label Studio endpoints. I couldn't find any documentation on version 1, so yeah, just set it to true. The next endpoint you need to know about is the setup endpoint. Now, it might sound like setup is a way for Label Studio to tell your backend, your machine learning backend to set up the model and get ready for data. But it's actually to pass project relevant information to the backend. This project relevant information includes stuff like the label schema that you saw earlier, an access token to access the data on Label Studio, the host name of where the Label Studio is set up so that you can actually make calls to its endpoint, its API endpoint. So Label Studio is also running an API that you can call into if you need to, which we'll actually talk about in a little bit, and stuff like that. This is called multiple times. I want to emphasize this is called multiple times. You do not want to set up your model in the setup when the setup endpoint is called. Otherwise, you'll be setting up your model many times and wasting a lot of compute resources and basically slowing everything down. It is absolutely required, and it expects a response of your model version and a string that identifies your model version. Now, this could be a static string if you want to, but that's not going to be very smart. What you want to do is actually return the something that you know is your current model, because you're going to be able to see which predictions were made by which model version. So if this is up to date with the current model that you're running, then you will actually be able to know which ones are the more important predictions to take a look at. There's a way you can do this automatically, especially if you do stuff with, say, MLflow. If you haven't seen the MLflow webinar that I gave, it's available on YouTube. You can watch it later. But I'll show you really quickly in a little bit how I set it up so that I'm always setting up this model version string based on the latest version of the model that I'm pulling from MLflow and the version number. That way I know it's always up to date. And then, of course, predict. This is the important one, especially if you want to do prediction, right? So this is how Label Studio requests predictions for tasks from your machine learning backend. Tasks, of course, as I mentioned earlier, include info about the data to predict. It does not send images or audio files as bytes to your machine learning backend. It sends links to files as repo URIs. These repo URIs can be easily converted into a URL from which you can then download the machine learning, the images or the audio data or whatever data you have. And I can show you how this is done in our example machine learning backend in a bit. Predictions can be returned directly as a response to this predict request, but I do not recommend this. This is not a good idea because Label Studio will time out after about 30 seconds or so on its side. So if your predictions take a long time to run, or if you send a bunch of tasks to your machine learning backend, then most likely Label Studio is going to time out and cause errors. Instead, what you can do, I mentioned Label Studio has an API that it runs on its side. You can make a request to a Label Studio API endpoint to return a prediction as you predict, and I'll show you that in a bit. This is the way also, so ideally what you do here is you run your predictions on a background thread, and then you return an empty list or an empty array back to Label Studio. Label Studio is fine getting an empty array back from your machine learning backend as long as it's a valid response. And then your background thread is calling into Label Studio and updating its predictions by sending it one at a time that way. And the last endpoint is the train endpoint. And the train endpoint is cool because it sends you really cool pictures of trains. Okay, that was a very bad joke. I apologize. I'm very good at bad jokes. I'm a dad, so that's my thing. It's a way you can set up Label Studio to actually start automatically training your machine learning model when annotations have been made. You'll see in a second when I set up the machine learning demo again for you. You'll see there's going to be a switch or a checkbox for train a model after annotations have been made. And this endpoint will be called so you can update your, automate your labeling process even more using this. And this is obviously optional. You don't have to do this. Okay. All right, let's go back. So we did the demo already. I don't know why I wrote demo here, but let's go into a little bit more detail here. So we're gonna go back here. I'm going to go back here and we're going to set up, we're going to go into my machine learning demo. And I'm going to show you the settings I used to set it up. Let me make sure the backend is still running. Backend is still running, great. We're going to see Heidi, hi Heidi. Okay, we're gonna go back to settings. And the way you would set up your machine learning backend is you go to machine learning in the settings. You'll see here is that checkbox that I mentioned where start model training after annotations are submitted or updated. This is the information about my machine learning backend. Initially, this wasn't there. I would click add a model. I can type in the name of model, my cool model, and then I can put in the URL for accessing that model. In my case, my home IP address and 9090 as the port. And then you would click validate and save, which would then call the health check and then the setup endpoints on your machine learning model. And provided those respond properly, it will add this model to your labeling process. Let's see, you can also edit or delete it if you need to change something. Okay. In order to get back to the Label Studio, interface, we want to just click save here. Even though it looks like I might be adding more tasks again, it says generating annotation tasks. Label Studio is smart enough, and DagsHub is smart enough to not generate the same tasks multiple times. So it's not going to give you 2 tasks for every image that you've had or anything like that. So you can safely click save and not have any problems there. I regret not going through the labeling interface. I think that would have been faster. So you could have also gone to labeling interface and click the save button there again. And that would also take you to the UI. And I think that would have been faster this time. I don't know what's going on. Oh, it's calling my machine learning backend a whole bunch of times for some reason with health and setup checks. All right, let's try doing it this way. Because I am impatient and I know you all have better things to do. Well, not better things to do. Well, better things to do than watch a loading screen. All right. Hi, Heidi. We're back to our screens. Okay. So I mentioned earlier that the machine learning backend sends prediction scores. So you can see the prediction scores here. If you were to, for instance, if you were running an active learning pipeline, what you might want to do is sort by prediction score, so that you can figure out what the hard data points are for the model. For instance, it thinks with 32% certainty that there is a squirrel here. And if we click here and look, that's not a squirrel. So what we could do is we could work with the ones that it's very unsure about and definitely add those to our data set. But I didn't want to just show Label Studio again. What I wanted to do was show you the backend that I'm using. So this is the repo that I'm using for the backend. I forgot to show you the QR code. So we go back really quickly. I can show you the QR code. This is a QR code to access the repo that I'm showing you in the machine learning backend. And again, we can get that link to you later if you need. This is where everything interesting that happens. So the Docker stuff is pretty standard. Docker stuff, we're not going to get into Docker here because that's out of the scope of this webinar. We might hold a Docker webinar in the future if people have interest in it. If you do, let us know, and we'll definitely keep that in mind. Let's take a look at the app. And what we want to do in the app is make the screen easier to read for you all again. We want to take a look at Relax ML. This Relax ML. You know what? Let's go. Yeah, that's fine. This Relax ML is the starting point for all of your logic, for all the logic in this web service that I'm running here, or that you can use. You can use this as a starting point for your machine learning backends. The Relax ML class gets instantiated by the app. The init is, of course, a great place to load your model instead of variables. For instance, these are variables that I know we're going to use and get from the setup endpoint. These are often environment variables that I'll use for accessing stuff from DagsHub. Here is where I would load our model. And why don't we just actually see the example? If you go to the Squirrel example branch, you actually see the code I actually ran for the demo. All right, that's a little bit cooler, right? So this is basically my loading the model from our MLflow registry, and this is where I set up this is where I set up the model version in a automated fashion. So I know that the model that's being loaded is the most current one, and the correct version is being sent back to Label Studio, so that I can match my model with the predictions that are coming up. The setup function is the one that's going to be called every time the setup endpoint is instantiated. And so that's why I don't do any model loading here. But I set up, I copy over the project. I copy this, the setup comes with a label schema. That's the label config.xml file, basically. There's a parse config function that comes with Label Studio tools that is handy for parsing that file. And then we can access a lot of stuff from that, including all of the names of our labels. So if here we just have squirrels, but if we had our Baby Yoda project, there'd be Baby Yoda and Mando in there. The predict function is the function that gets called every time the predict endpoint gets called. And this, we get a list of tasks. So we loop through the tasks. Remember, the tasks are the data that we want to annotate. We grab the URI of our image. This URI is that repo : / remember. So there's a handy function URI to URL that's in the repository that we can take a look at later if you want, or you can look on your own. That'll convert it to an HTTPS URL that you can then download the image from. So this image path is now a local image on our web server. We can open it with Pillow, get the size, and we can run our model prediction on it. Once we've done that, we have our objects, and we just need to convert that into a Label Studio format for the predictions. One kind of caveat gotcha that you want to keep in mind is Label Studio doesn't want bounding boxes to be, or coordinates to be in the range 0 to 1. It wants them to be in the range 0 to 100. So if your bounding box starts at the 75% mark, it's not looking for 0.05, 0.75, there we go, got it right finally. It's looking for 75. Here we just create our prediction, or basically the prediction JSON that we want to send back to Label Studio. along with the coordinates and a bunch of other stuff that it needs to know. This is basically boilerplate stuff, and our score, which is our confidence level. And then we set up the result JSON. That's the one that we're actually going to set back. So this is the result of our image, the model version that we saved off, that we created during the setup, and then the task idea. And this task idea is how Label Studio is going to associate your prediction with the task that is sent you. Without this, it wouldn't be able to do so. We then call the send predictions function, which just is basically an HTTP request to a URL that we can generate. This is the entire Label Studio API that you can access is under DagsHub.com. The owner repo name, annotations API. Everything after this is your Label Studio API endpoints, and there's one called predictions, which is where Label Studio expects predictions to be sent. We just send this with our auth, expected 200, and that's how we get our predictions to Label Studio. I know I'm going over this fairly quickly, and that's kind of on purpose, and I'm sorry if I lose you, but please do take a look at this on your own time and try to go through the code. It's pretty self-explanatory, but if you have any questions, you can always come to me or ask on our Discord channels later. Okay, a couple of things that I wanted to show really quickly. If we have a couple minutes, we have a couple more minutes. Let's go back to the app. The utilities, I just wanted to show you how the repo URI gets changed to the URL. And that's basically, the repo has link data, which then can be split into a commit hash and a tree path, which then get added to basically the DagsHub raw URL endpoint. And this is how you are going to download your images. One last thing that you should see is the endpoints are all defined in main.py. This is where the fast API application is created. This is where our RelaxML class is instantiated. And we have a couple of things you have the option with fast API to define a startup event. So it only gets called once when the app is created. This is just to set up basic logging. We have the predict endpoint here. And what this does is it creates background tasks to call our predict function on each of the array of tasks that we get from Label Studio, and immediately returns the array. I mentioned earlier that you want to spin up the prediction on a background task, and that's what this is doing for you. So that we don't get timeouts in Label Studio. The health status is fairly straightforward. You'll notice I wrote false here, even though I said true in the presentation. So I guess false also works. It probably doesn't matter that much. My guess is that the endpoints that I used did not differ from the version 1 or the previous version. And then finally, the setup one, which sends the setup data to the Relax and then returns the model version that we created in Relax. Okay, that's a very quick overview of that machine learning backend that creates predictions for Label Studio. If you look in the main branch, this is a good starting point if you want to configure it for your own projects. And of course, if you run into any trouble, we're here to help get you out of trouble and get you on your feet and working. I think that was the end of dessert. I hope you enjoyed it. I hope you enjoyed your whole meal. And don't forget to join our Discord community where we have support channels and other people doing cool stuff and a lot of activity going on. It's a great community. It's a lot of fun to check there, and all of the DagsHub people are on there too. So we're here to help you as much as we can.